Welcome to the studio of Simplified EGD, your go-to learning space for mastering engineering graphics and design.
Welcome to the studio of Simplified EGD. Today we are going to learn about engineering curves. There are mainly 4 types of engineering curves that we are going to learn. We will cover 4 types of engineering curves. First one is conics, another one is cycloid, third one is involute, and fourth one is spiral. Now, what is conics? So, here we will see the section obtained by the intersection of the right circular cone. That is a cone having equal shape and size from the center. Okay, so the right circular cone by a cutting plane in different position. Cutting plane will cut this cone at different angle, and the entity generated, that is called as conics. A section obtained by the intersection of right circular cone by a cutting plane in different position relative to the axis of cone are called as a conics. So the section obtained by the intersection of right circular cone by a cutting plane in a different position relative to the axis of a cone are called as conics. Means, suppose there is a right cone. This is cone. There are different portions. This is called the base of cone. This line is called as a generator. This point is called as apex. We can draw a center line here because it is a circular entity, so it is called as axis of cone. Let's say this make an angle of alpha. Generator makes an angle alpha with the axis. So there is a cutting plane which cut this cone by different angle. Okay, so we will see that in a deep, let's say there is a cone, a cutting plane is cutting this cone by passing through this apex point and from its axis. I have darked this center line and show the arrow that indicate this portion we have removed. So how it will look? It will look like this, something like this. Okay, so here the entity generated is called as triangle. Okay, then suppose there is a cone. This is its axis. Okay, now it is cut by a horizontal plane and we are removing this portion. So here the entity generated like this. Okay, when we see from the top, it will be a circle. Okay, now generator makes an alpha angle here. Okay, so let's draw 3 cones. Means there are 3 possibilities that we are going to see here. Okay, these are your cones, these are axes. Axis makes an angle of alpha. Okay, now a cutting plane cut this cone with the angle higher than the alpha, means theta is greater than the alpha angle. So here the entity generated will be ellipse. Suppose a cutting plane generating angle with axis theta that is equal to the alpha. So here the entity generated is called as parabola. Okay, and if your angle with axis is theta which is less than alpha, then here the entity generated is called as hyperbola. Okay, so in conics there are 1, 2, 3, 4, 5 curves includes. Okay, conics have 5 curves. First one is triangle, circle, ellipse, parabola and hyperbola. So these entities are called as conics, which is generated by a cutting plane to the regular cone. Which entities are called as conics? So first of all we will see triangle, then circle, ellipse, parabola and hyperbola. These curves are called as conics. How? So here we will see when there is a cone, here we can see a cone is cut by a horizontal plane. Okay, a cone that is cut by a horizontal plane means 90 degree to the axis, and we will remove the above portion. Then the entity generated here at the top of the cone, when we see from the perpendicular direction, it will be look like a circle. So that is called as a circle that is generated through conic. Then after ellipse, here you can see there is a cone which generator makes an alpha angle with the center line, okay, with the axis. Now the cutting plane that's make an angle theta. So here theta that is greater than the alpha. So entity generated by this is called as a ellipse. Okay, when you see from the top it will look like a circle, but when you see perpendicular to the section it will look like a ellipse. So ellipse is generated through the cone. Next is parabola. So in parabola you can see the angle of a generator that is equal to the angle of the cutting plane. So theta is equal to alpha here. So entity generated by that is called as a parabola. Next one is hyperbola. Here the angle alpha, and here it is the angle of theta. Here theta is less than alpha. So the entire entity generated by this cutting plane is called as a hyperbola. And the last one is, now two more. If a cutting plane is perpendicular to the base, okay, that is perpendicular to the base but parallel to the axis but not passing through the apex, then the entity generated is called as rectangular hyperbola. And if that perpendicular plane is passing through the apex and perpendicular to the base, then the entity generated is called as triangle. Here plane is passing through the apex but that is not perpendicular to the base. Here it is making some angle, let's say phi here, and here angle is theta. Okay, on that time the triangle is generated, that is called as isosceles triangle. Next one is cycloid. There are three types of cycloid. First one is cycloid, another one is epicycloid, and third one is hypocycloid. If there is a circular entity which is rolling over a flat surface without slipping, and if we trace path of any point on this circular entity, the path we get, that is called as cycloid. Okay, suppose there is a circular entity over which another circular entity is rolling without slipping for one revolution. On that time, the path traced by the point, that is called as epicycloid. And an entity that is rolling inside this circular entity for one revolution and path traced by that curve, the path trace of that point, that is called as hypocycloid. Okay, next one is involute. Suppose there is a line on which we have wind string. Okay, on which we have wind a string. Now during unwinding, string will open like this, B point will be center, string will be unwind like this till this point. Okay, till this point. Then after, center point will be changed, it will make A point as a center and it will unwind like this. Okay, so this entity generated by tracing the end path of the unwinding string, that is called as involute. So we are going to learn involute of line, triangle, square, rectangle, pentagon, or we can say polygon, means pentagon, hexagon, heptagon, everything, and a circle. Okay, next one is spiral. There are two types of spiral. One is logarithmic and another is Archimedean. So how the spiral entity will be generated? Suppose there is a long road, okay, or maybe let's say there is a pen. You are revolving this pen like this, okay, in clockwise direction you are revolving. Okay, on the same time there is an insect which is traveling from this point to this point, and you are revolving this, let's say A point and B point. You are revolving this pen by keeping B point as a center. On that time an insect is traveling from A point to B point. So what will be the path of that insect for one revolution? Okay, so we are tracking a path of that insect. For initially it is here, then after it is here, it is here. As the one full revolution will complete, insect will be here, so its path will be in a spiral form. There are different methods to draw the different curves. To draw the ellipse, there are mainly 6 types of methods: focus and directrix method, concentric circle method, rectangle or oblong method, parallelogram method, arc of circle method, oblique circle method. For parabola there are 4 types of methods: focus and directrix method, rectangle or oblong method, parallelogram method, tangent method. And for hyperbola there are 3 types: focus and directrix method, rectangle method, and foci and vertex method, that we are going to learn in further lecture.